Okay guys, here we are again. So we just finished the factoring binomials notes, and then you had your worksheet, and then there was a blank page because of trying to keep everything intact. And then the next page in your worksheet should be this vertex form page. Now this vertex form page is designed to be an assignment about vertex form. So we're going to give you some paper notes this time that you might have to follow along and copy. But these are just going to be some quick notes to remind you about vertex form. But we're going to start talking about quadratic equations just kind of in general. So to start with quadratic equations, there are three forms of the equation, okay? So there are three forms for the equations. And we're going to each week kind of walk through the different forms. The first form that we're looking at is vertex form, of course, because that's the worksheet that you have. Vertex form is a form that you are familiar with. Remember the green packet that we did before Christmas where we did all the transformations and stuff, we were moving parabolas around. And vertex form is our AHK form. So this is our AKA AHK form, which should help you remember what that equation looks like. So this is going to be y equals a x minus h squared plus k. Right, so that's vertex form. We're going to look at that here in a little bit. The second form we're going to look at is standard form. And standard form we've seen also. Standard form is y equals ax squared plus bx plus c. Right, we've seen standard forms of equations before. And then the third form that we're going to look at is called intercept form, or we're going to say AKA factored form because sometimes it's referred to as that. And if you can think about that we just spent the last notes factoring, this equation is actually y equals a. A is always out front, but this is going to have the factors in it. So this is this, and then in order to denote the factors, we say x minus p and x minus q for some reason. And so we're going to, over the next couple of weeks, look at these three different forms about quadratics. Also, just to remind you about quadratics, quadratics are parabolas, right? All three of these forms, if we graph them as parabolas, right? So this is like our upwards parabola, or it might go down. And so we're going to look at all the different versions of that. But as we solve quadratics, which is going to be in each section as we talk about each one, we're going to talk about, well, how do we solve each of these? So the solutions to a quadratic, solutions for quadratics are these basically. So you could have an instance where, let's do it like this, right? Where your parabola is just centered at the origin here, like the original, and it crosses one time, right? So this has one solution. It could be a parabola. Can we see these? Yes. It could be a parabola that is moved down a little bit, and so it might be fat, because they all look different, right? And here, this has two solutions. So hopefully you're going, oh, that's right. Solutions are where the graph crosses the x-axis. And our third possible quadratic solutions is, well, what if it's a downward facing parabola, perhaps? Could also be upward. But let's say it's a downward facing parabola that goes like this. And maybe it doesn't even ever cross the x-axis. This is one where there's no solution. Right? And we'll talk about that later. We say no solution, but that means there are two imaginary ones. And we've talked about that before. Do you remember where we've talked about the reflection, where here's my parabola here, but it would do this if it were reflected. And so it has two imaginary solutions that don't physically are a part of the graph. So those are our imaginary solutions. So you can have one solution, two solutions, or no solution. Two imaginary solutions. When I say no solution, I should put the word real in there. Because if they're not real, then they're imaginary, right? So no real solution, there's two imaginary. This is going to be two real solutions, and this is going to be one real solution. So keep in mind that as we're looking for solutions, right, solutions are the x-intercepts. So sometimes it will refer to solutions as solutions. Sometimes it will call them x-intercepts. Sometimes it calls them roots. Right? Sometimes they're called the zeros. Do zeros have an E? No. Right? So this is what you need to keep in mind, is that solutions are also called x-intercepts, roots, and zeros. And you're going to find that all throughout the next couple weeks as we go through. So that's kind of a quick review about quadratics. Let's go ahead and get into vertex form. Or no, I forgot one thing. So part of the parabola, right, let's graph a good parabola here. This is my home paper on yellow. I would normally use white paper with you guys, as you know. But let's go ahead and say that this is like this. We'll space it out by ones so we can graph a good one, and we'll get this all working. Hope you guys are okay as we're doing this and following along. And it's kind of nice maybe on video because you can pause and rewind if you didn't catch something. So remember, if we were graphing y equals x squared, right? This is our parent graph. So if I plug in 0, y is 0. If I plug in 1, and 1 squared is 1, so y is 1. If I plug in -1, -1 times -1 is also positive 1, right? So this is where the parabola starts to come in. If I plug in 2, 2 squared is 4. So 2 is at 4. If I plug in -2, -2 times -2 is also at 4. And so remember, it's not linear, it does curve, right? And we want to put arrows on it always to show that it goes forever in that direction. So there's our good parabola. Okay, so now we have parts. Let's name them. So this is called the vertex, right? So that's called the vertex. The other part that we need to know is a line of symmetry. And the line of symmetry is, where is that line that I can fold the parabola over, so that if I folded it over, it would be exactly the same, right? So like if you take your hand and you fold it over, it's exactly the same but reversed, right? That reflection. So that is called the line of symmetry, and that is always through the x-axis, through the x value of the vertex. So this is called the line of symmetry. Oops, we can't see it. It's down too far. There we go. Right? So this line right here is called the line of symmetry, and it has an x equals whatever number, right? equation. That is the equation for that. And a vertex is always x comma y. Now, the number is always this x value, right? So whatever that x value happens to be, in this case it's 0, right? So if we were saying the line of symmetry for this equation, we would say that it has a line of symmetry as x equals 0, and it has a vertex at 0, 0. Now, this vertex, the last thing, is if the graph is coming this way, then this is the smallest y value that that graph is going to be, because it starts to go back up the other way. So big y values coming down, 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 hits 0, and then all of a sudden my y values start going back up. This is the smallest value this can be. The vertex determines whether it's a maximum, right? Maximums would be this way, right? Or a minimum. Can we see? No, I'm writing off the paper. Minimum. And that's if it's this way, because it's the lowest that it can be. So here's the max value, here's the min value, right? So as we're talking about parabolas, those are the things that we need to keep in mind. Okay? All right, so let's go ahead and look at vertex form real quick. Actually, I'm going to tear this off. Go over there. All right, so let's go ahead and take a look at vertex form. This won't take too long because you're very familiar. So vertex form, remember again, is going to be y equals a x minus h squared plus k. So we know already that this is my left, right, and this is my up, down. And if that's the k, that means this form of the equation, it's called vertex form because I know my vertex is going to be at hk, right? That's just something we know. If I know my vertex is at hk, then I know my line of symmetry is going to be x equals h, whatever that value is. We just talked about how the vertex, right, the x value of the vertex is actually my line of symmetry. So we're going to say that my vertex here is hk and that my line of symmetry is x equals h. And that's pretty much what you need to know. Based on that, you can make a table or you can graph, you can plug the values in and so forth. Remember that A describes two things, just real quick. A, if it's positive, will open up. If it's negative, will open down. If it's greater than 1, right? Do you remember what happens when the numbers are greater than 1? It means I'm multiplying by a lot, so it stretches, right? Or it's going to get skinny. Sorry, you can't read the skinny there. And if it's less than 1, right, then it's going to compress. It pushes, right, onto the paper, so it compresses, or it widens, right? So kind of keep that in mind. Okay, so let's just do one example so we can name all the stuff, and then I think you'll be okay to get started based on all the stuff. So let's do one example, and we'll say let's graph, what should we do? Y equals 2x minus 3 squared plus, plus something? No, let's say minus 2. Okay, so let's go ahead and do that example. So let's first graph, right? So again, I'm just gonna kind of oh, you could use that graph paper if it copied well in the notes there. I'm gonna go ahead and just go by halves. I think this will be plenty of room. Try to space your x-axis out the same as your y-axis. So that your graph comes out, okay? So once we've got a good enough graph to get going, where do we start this parabola, right? So my vertex is where? So if you remember this -3, does this go right or left? Right, -3. These are the ones that go opposite. So this is actually going to go right 3, and then this is going to go down 2. So as I label my vertex, right, my vertex is going to be at +3, -2. Right, so we know that already without even having to graph. So I'm going to go right 3, down 2, and I'm going to put my vertex right there. Then I can make a table if I want. If I use the graph that we just made of the parent graph, right, you can just move that and do the things that you need to do to it. It just kind of depends on how you like to graph. But remember that this has a multiplier of 2, so it's not going to be exactly the parent graph. We've got to multiply, so it's going to stretch. So let's just plug in numbers. So if I plug in 2, right? So we're going to get what? So I'm just going to write it over here. Plug in 2. So we're going to get 2. Can we see? Yeah. 2 times 2 minus 3 squared minus 2. Well, 2 minus 3 squared is -1. -1 squared is just 1. 2 times 1 is 2, minus 2 is 0. So 2 is going to be at 0. But because it's symmetric, what else is going to be at 0? Right? So 3 was at -2, 2 is at 0. That means on this side, this is also going to be at 0. So we want to use what we know about parabolas to make it easier to solve. If you want one more value, this is the values we need, right? Or where does it cross the x-axis? If you want one more value, you can plug in 1 or 1, 2, 3, 4. You could plug in 5 because we had the negative value there. If you want to plug in 5, let's see, do I have room? We know it's going to come there, so plug 5. So what would we get? 2 times 5 minus 3 squared minus 2. 5 minus 3 is 2. 2 squared is 4. 2 times 4 is 8. 8 minus 2 is 6. So this is actually going to be up at 6. So 2, 4, 6. That means 1 is also going to be at 6. And so now you have a better picture if you'd like. Right, I'll put our arrows on the end to show that it goes forever. And there's our parabola. What are the things that we want to know? Well, 1, vertex. 2, line of symmetry. Right, and it might just say LOS or whatever. But we're going to say line of symmetry is at 3, right? Through that vertex. That's where I would fold it over. So we're going to say x equals 3. And my solutions, right? My roots, let's call them roots for this example. My roots are where does it cross the x-axis? And in this case, our x-axis is here. So where does it cross? 2. So we're going to say x equals 2. And x equals 3, 4. And so these are the important things right here, right? You have a vertex at 3, -2. You have a line of symmetry at x equals 3, and you have roots at 2 and 4. And that's pretty much everything we would do with a parabola. We could say this is a minimum or a maximum, no. Oh my goodness, Miss Stevens. This is a minimum value. It's the lowest it could be. So we would say this is the minimum at -2, right? So we could say min at -2, right? You could also describe that. Just depends on what you're being asked for. But that's pretty much it. Like I said, you already know how to do vertex form. So this worksheet should be pretty straightforward. Let's go ahead and take a look at it real quick. So on the top here, write an equation for the parabola given the pieces of information, right? So if you have your vertex, right, your vertex is going to be HK. The point is going to be XY. So you're just trying to figure out what A is. We can do one of those real quick. And then you're graphing and so forth. Then at the bottom here, you have the graph. So you're trying to identify what the equation is. So where is the vertex? Pick another point, write the equation out. And then on the back, it's given you an equation, and you're finding where's the vertex, where's the axis of symmetry, or the line of symmetry, I suppose. The vertex, right? Is it a max or a min? Where's the y-intercept, right? You have to graph to find the y-intercept. And then solving the quadratic equations, which is basically like square rooting, right? You're going to solve them to get the square roots. So real quick, y-intercept stuck out to me. So let's go ahead and do the y-intercept real quick for this problem. To find the y-intercept, you need to basically multiply the equation out. So if your equation is y equals 2 times x minus 3 squared minus 2, I need to multiply this out so it's in standard form. So to find the y-intercept, right, put it in standard form. Right, that's what we want to do. So we're going to multiply. So this is really going to be 2 times x minus 3, x minus 3. So we have to do this part first, the x minus 3, x minus 3. So I'm going to do 2 times, and I'm going to ignore that, x times x is x squared, minus 3x is minus 6x, minus 3 times minus 3 is plus 9. And I know I went kind of quick through that, but you should be multiplying fresh in your brain, so that should be good. Next thing we need to do is distribute all of this, the 2. So 2x squared minus 12x plus 18. And then notice the 18 and the 2. And this is the y-intercept right here. Plus 18 minus 2 is really going to be plus 16. And this is where it's going to cross the intercept. So this is my y-intercept. Right? So when it's asking, I suppose we could come back up here and go 1, 2, 3, 4. If it's asking for the y-intercept, right, we have to put it in standard form, and then you know the y-intercept is going to be at 0, 16. So that could be something else that's asked. So let's go ahead and just do the first problem here on your worksheet to remind you that you already know how to do this also, but we'll do this together real quick and we'll call it good. So if the vertex, right, that's my HK, so here's my formula, right? So we know XY, a point is always given because it's XY, and we know my vertex is HK. So we're going to plug in everything we know. Y is 4, A we don't know, that's what we're solving for. X is 3, minus H is 1 squared, plus K, so plus 2. And so we're going to solve that equation for A so that we can have A. So we're going to say 4 equals A times 3 minus 2 is 2. So this is going to become 2 times 2 is 4A. And now I just solve this equation real quick. So we're going to subtract 2 from both sides. That will give me 2 here. And if I divide by 4, right, a is 1/2. And so my equation is going to be y equals 1/2 x minus, and I'm going to use the HK, right? So x minus 1 squared plus 2, and then you graph it. And I'm not going to walk you through that, you guys. We just did one. So that's pretty much what you're doing for 1 through 3. We've done this process a lot, so you're just finding the equation. Same thing down here. It's the same thing except it's giving you the graph. So you first identify the vertex. Where's the vertex? Vertex is going to be here. So -1, -4. Pick some other point on the graph. It doesn't matter which one. You just need an X and a Y. Try to find an easy one. So maybe this one here, right? 1, 0. That way you're plugging in 1s and 0s. And then you're going to do the same process as number 1, right? And find the equation. Okay, that should take you through vertex form. Like I said, the next form will be standard form that we go through. And after that will be the factored form or intercept form. Okay, hope that made sense, you guys. Thanks for sticking with me. I really do miss teaching to students. It's weird just talking through this myself. I know I'm going a little fast, but like I said, please use the technology to help you. So call with any questions. Do your best. Let me know how it goes, and I will talk to you later. Bye.